Hi, today we're going to take a look at the support generation capabilities of Netfabb 2021. What we're going to see is mostly based on metal 3D printing, but it can easily be applied to other technologies as well, such as resin or extrusion-based printing. The part that we are dealing with today is already oriented and placed on our machine workspace. Let's enter our support module via Generate Supports and see how to place and generate supports right where we need them. We are typically starting with the cluster detection. The cluster detection shows critical and uncritical areas that require support. The red colored areas that you see can now be selected to either apply support manually with the tools that you see here up front, such as bars, polylines, or even volumes. Even pre-configured supports can be added just like that. So now we see that we have applied a volume support or block support to our part. When it comes to automating this process, support scripts are the way to go. They combine cluster detection, so basically what we've seen before, and support types in specific support actions and allow quick and easy support generation. They are typically designed for different use cases, such as smaller or bigger parts, or even for different technologies. Netfabb comes with a set of predefined support scripts that we can use to develop our own support strategy. What we're seeing here is the standard support for our SLM process. It looks pretty good so far. However, we can see that the combination of volume supports and the cluster created some areas in which we do not have a support, even though there is it's strongly recommended to place a support around these edges. So what can we do? At this point, I'm going ahead and create a copy of this support script and add another support action to enrich our support. Here I'm going for an edge with polyline action that should place a support right under these red marked edges that would normally be melted directly into the loose powder. A support script, just as this one, typically gives you access to edit it in any way you want. Starting from the top, we're seeing quite many action-specific properties, such as the edge length, the polyline curvature, neighboring aspects, anchor distance, all of those things. Typically, when it comes to editing support, you can impact the detection mechanism, so the cluster angle, the cluster size, but you would also have support specific properties. Think about your block support, the size of the hatching, in this case, how the volume, how the polyline is going to look like. So all of these things can be edited within your support script. Our plan, in fact, did work. We were able to support the little feet of the part with the polyline support that we have just added. However, considering that these supports have a very high aspect ratio and will potentially undergo a lot of distortion during the build process, it might make sense to thicken them up so that they are more stable, more rigid, and do not bend under the process circumstances. With the thickened supports on the edges now looking very good, we would like to go ahead and add another support action to assist the regular volume block support that we have right now. And we're going for an area with bar supports. And these bar supports should be volume supports as well, as we want to have them cone shaped and made out of full material. So as they are right now still cross-shaped, we just need to make sure to change these properties under the support section here on the right to make sure that we use a cylindrical or cone-shaped style for our support. Our improved support script seems to do a very good job, as the combination of all three supports seems to be a very stable way to go into the process. However, as we can see, there are still ways how we can optimize the support script. When it comes to scripting, the majority of the time you are going to be fine without no further indication, without any further post-processing. However, in this specific case, we are going to see an area of the part that is now being hit by the support twice as the support is starting to grow out of the part. This would cause additional post-processing steps on surfaces that are initially not planned for additional post-processing. So what we can do is now we can certainly optimize the support in a way that we can take the support out and delete unnecessary support elements, just as the bars that we can click on and manually delete as we go. The outcome of a support script is typically seen here in the list. Every single support that is assigned to a part can now be individually found and modified as we go, either as a group belonging to the group that are assigned to, or based on the cluster that they have been added on. So here on this specific area, we're going to make sure that we reduce the impact of the support on the specific surface that we're seeing right here. We're starting with selecting the individual bars that we don't need and delete them simply by pressing the remove button on our keyboard. In the next step, we're going to take a look at the volume support that we have just selected. By doing a right click and going into the edit mode, we can now have full control over all the properties that we've already seen in the support script, but instead of changing them globally, this will only affect this specific support that we have added. A clever way to do it is to assign the angled support characteristic to our specific support right here, which leads to the fact that we are then able to bend the support around the areas where it shouldn't be and still maintain the support characteristics that it should have to support the area that it has been designed on. Dragging the support out is facilitated using clip lanes so that we can make sure that the support is not touching the internal area of the part at all. Our support is now designed and we are ready to take it up to the next step. For the next part of our demo, we would like to take a look on how to apply the support that we've just created onto multiple parts. So what we have right now here on our machine workspace is the part that we have just worked on, the SN1, serial number 1, and 5 other different iterations of the part, 2 of them being identical, then something with a change geometry, and parts that are slightly bigger than the one that we have just worked on. So typically, you could go ahead and access the same support script that you've also applied beforehand, also from the main menu, running scripts, running support script, and changing picking the one that we've just created. That is something that we could do at this point. However, running a script is not going to give you the same results back as on what we did with our first part, due to the amount of manual optimization, especially in the bottom area. So we have to find another way. In order to apply our support to as many parts as possible in the quickest way possible, we have to take a look on the Manage Support menu right here. Manage Support is where you would normally find ways to split the support and have it as an individual part. This is good for everyone who wants to export a support separately and uh, bring it into the post-processing tools, refreshing the support, merging solid support areas with the part to create one component. But for us, it is now important to attach a clone support. For that, I'm going to mark all of the other parts, say attach clone support, and pick the initial part that we've had on our part. Yeah, it should be this one. Important here that you take the automatic alignment and then the support will be aligned to the part right away. Now the support should be adopted perfectly, and as we can see, the parts also obtain the manual improvement, the manual angle supports as we go. Should it not fit on the first try perfectly, as we can see here with the parts that I have scaled up a little, we can once again refresh the support also out of the Manage by Support area, and then the support should be placed accordingly. This was the first one, and now the second one. And now all of the parts have been supported based on the support strategy that we developed once and applied in a very quick way to all of the other parts with just a few clicks. For the last part of the session, we want to focus exclusively on metal 3D printing, as we are now looking into a build process simulation. We are seeing here simulation results that I have created with Netfabb Local Simulation. As we can tell from the color coding, the part is heavily distorted. After linking the simulation results with our part, we can get an impression about the color coding also on the machine workspace, as we are obtaining a new file, a new part that has the same information as in the mechanical results. And we can now, based on this file, already have an impression on where we need to improve our support geometries. Alternatively, we can also link our mechanical simulation results directly with the support generation and see in the best way possible on which positions support has bended, which areas have deformed, and how we can impact these by improving or adding another support here and there. Additionally, Netfabb also offers automated optimization possibilities that work extremely well with bar support. Using a density map allows us to apply a yield stress for supports that is then applied to all of the bars so that they are adjusted in a much better way. Additionally, you could also optimize your support lattice according to the support criteria so that they better fit your use case. Last but not least, we do also have the possibility to use a manual density map that allows us to impact the size and the thickness of our bars in any local area, as we can see right here. This was my short take on creating supports with Netfabb. We have seen how we can manually apply supports on a part, create and optimize support scripts to fit our need, clone supports on multiple iterations of parts that are either similar or even very different, and use simulation results to get an impression how to effectively optimize a support based on mechanical results out of Netfabb simulation. Thanks for your attention. Bye bye.